We are very glad to present you our final blog about thermodynamics equilibrium. We are students of chemical engineering from Tec de Monterrey who are forward to increasing their professional experience throughout didactic resources. Our objective is to transmit our knowledge to people who are interested in thermodynamics equilibrium. If not, make them become interested and passionate about the magic of it. Why is it important? Thermodynamics equilibrium illustrates the importance for thermodynamics of the concept of temperature.
Thermodynamics is defined as a branch of physical science that deals with the relations between heat and other forms of energy. Thermo refers to the heat and dynamics refers to the movement. So, equilibrium thermodynamics is defined as a systematic study of transformation of matter and energy in systems in terms of a concept called thermodynamic equilibrium. The word equilibrium implies a state of balance. The equilibrium deals when the change in entropy is equal to zero, the static condition and the lack of change. We can say a system is in thermodynamic equilibrium when there is thermal, mechanical, and chemical equilibrium, so the change in each of these ones is equal to zero, and the state more stable is when there is less energy. As we're talking about thermodynamics, there is a relation between the laws. The first law of thermodynamics states that the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can be neither created nor destroyed. This is referred that heat plus work is equal to the change in enthalpy. The heat is referred to the dissipation of energy, meanwhile the work refers to the displacement of order. And the second law states that the total entropy of an isolated system can never decrease over time. The total entropy can remain constant in ideal cases where the system is in a steady state or is undergoing a reversible process. This law deals with the spontaneity of a process, that is, when it occurs naturally without adding energy. Also deals with the direction of process because it is determined by spontaneity and the dispersion of energy.
Equilibrium is a state in which entropy is equal to zero. It happens when the system is at a static condition, there is a lack of change in the properties, and there is not a driving force. It is reached when the system has the greatest disorder possible and it won't keep increasing. It is different to steady state because steady state is when properties of a system like temperature, pressure, and concentration do not change with time.
In order to give a little more history of thermodynamics, two articles were published. The first one, published on September 29, talks about the beginnings of this branch of science, with the title, Have you ever wondered who discovered what nowadays we know as thermodynamics? In this article, mention is made of the beginnings of this concept, as well as the contributions of great scientists towards thermodynamics, which are now applied in the cases studied in class. Some of these characters are Clausius, Carnot, Joule, among others. The second article is titled, Have you ever wondered what are some of the applications of thermodynamics in the things we commonly do? And was published on October 15. It talks about the influence of thermodynamics in the activities we carry out on a daily basis. In short, thermodynamics is present in absolutely everything we do. Then, we have the concept of fugacity, which was a large part of what was learned and applied in the course. We will explain why it is so important in the study of thermodynamics equilibrium. It is an effective partial pressure which replaces the mechanical partial pressure in an accurate computation of the chemical equilibrium constant. It is equal to the pressure of an ideal gas which has the same chemical potential as a real gas. It is possible to have vapor phase fugacity and liquid phase fugacity. They are explained above. Then, we may have the case of vapor and liquid phase, putting them together. Fugacity can be obtained by three methods: equations of state, correlations, and van der Waals. We explain Lee-Kessler correlation, a way to understand and apply fugacity. We also present you a Lee-Kessler calculator. There are several programs that may do this, so as Thermosolver or Aspen.
In the tab about Gibbs phase rule, we explain the meaning of this rule. It gives a number of parameters that can be varied preserving the equilibrium. The rule is F equals to C minus P plus 2, where F represents the degrees of freedom, C the number of compounds, and P the number of phases. In the blog, we added two different types of equilibrium. The first one is located in the solid-liquid boundary, and the second is located in liquid-vapor boundary. In both sections, we can find explanation with Clapeyron and their equations, but there are some differences. In solid-liquid boundary, the process is endothermic, the slope will be large and the change in volume will be small. In a liquid-vapor boundary, the process is endothermic, the slope will be large and the change in volume will be also large.
You can always visit our social media of Twitter, where it's never too late to learn. We present you some thermoequilibrium facts with a did you know concept.
Fugacity to help the environment. Fugacity can be applied to a variety of environmental simulations of the fate and transport of organic contaminants. The challenges of estimating fugacities in environmental phases are discussed, especially for ill-defined phases such as soils, sediments, and biota, for which activity coefficients and molar volumes cannot be measured. It is shown that by lumping these quantities and a reference fugacity in a single parameter, empirical partition coefficient data can be used to deduce fugacities and thus the relative equilibrium status between phases and directions of diffusive transport. For assessments of substances that display narcosis, chemical activities, which can be readily deduced from fugacities, can provide valuable estimates of the proximity of calculated or measures environmental concentrations to potentially toxic levels. What that we have built so far as project development. First of all, we are glad that we have created this open educational resource to everyone with original ideas and help to the contribution in the new ways of learning process of equilibrium thermodynamics. In the view of needing more comprehensible material on the internet, the main objective of the platform was to promote science and motivate the students to learn topics in an innovative system. So, in order to achieve that purpose, this website has many elements to interact with and make a more dynamic experience to the users. Besides, the addition of social media accounts and graphic content provides whoever is reading it a complete knowledge of a recent data in the subject. As a result, we have managed to cover from the most basic concepts of thermodynamics to the most demanding topics like phase separation, partial molar properties, and fugacity, in which every single formula and concepts were also supported by class notes during the semester. Finally, we can affirm that the constant employment that any student could do to the website is now more accessible and simple, all given by a wide range of information sources such as articles, magazines, encyclopedias, and engineering books, which make our website the most efficient tool of learning new topics in equilibrium thermodynamics.
Last but not least, you can get in touch with us. We'll be glad to know more about you.